procedure. All right. Good afternoon, everyone. We are the Omega team. And right now what you're seeing is us setting up for our presentation on our multi-touch screen. Okay. There's myself. I'm Zoe. At the board we have Tedo, we have Ross standing over here, who's our artist, and Devleta as well. Our clients for the semester are heading that is Julia Gargo. We also have Matthew DeCrozier and Zella M. Sum. And our faculty advisor for the semester was Shirley J. Saldamarco. The Omega team is a research and development group that is focused on exploring the potential of multi-touch as a valid tool for the exploration, organization, and manipulation of data in both 2D and 3D workspaces. For the purpose of this presentation, we're focusing on the organizational aspects of 2D data, which you're going to see today. Currently, in multi-touch applications, you're seeing a lot of sizing, scaling, rotating images. Also, you see a lot of video being played, application of, as the multi-touch tool is glue, for example, for various different applications. But at the same time, there are research groups that are devoted to exploring the 3D potential of a multi-touch surface, using only gestures with the freedom from a mouse and keyboard, such as Google Touch Earth here, which we'll see here. And in this video, you can see that someone is controlling a 3D object with simple gestures, just by using their fingertips. Okay. You can go to the next slide. What you'll also notice is that these are actual slides. These are PowerPoint slides that we have exported into our 3D rendering program, which is Ogre 3D. We have a multi-touch screen, which I understand that it is slightly divided. Our experience was geared for 3 to 5 people in a meeting setting with one presenter. So for the purpose of today, your attention might be split between the two. But we also have our own multi-touch surface, and you'll also notice throughout the presentation that our slides are color-coded for the purpose of, at the end, if you have any questions and would like to bring up any other slides, we can very quickly and very easily bring up those various different media. We also have 3 different repositories for information. On the left-hand side, you'll notice a bar that has all of the slides, or on the right-hand side, these are all the slides that we've looked at so far. At the very bottom, we also have video and other media that we'll be referring from, including still images and video. So ultimately, what we're doing is visualizing the multi-touch screen as an actual solid workspace. But it is not necessarily just a novelty gadget. This is something that can potentially be huge. I mean, you have Windows 7 that's coming very soon, and it features multi-touch potential, but we're actually trying to foresee that, and not only what you can do with a workspace, but seeing a multi-touch surface as a glue for other different types of media. Right now you have text input and annotation that's being researched, and we're trying to conceptualize that, and also we've also made efforts to implement that in our workspace. In the future, we might even have timestamping ability. Right now, there are research groups that are trying to focus on recording not only light blobs, but also hand recognition. So if you can record someone's hand, or you can potentially remember what someone has worked with at any particular time. Ultimately, what you have is a recording space that can record an individual's identity. I apologize. That can record someone's, yes, sorry. That can record an individualized session with a multi-touch workspace.
Let us look at some of our project goals. The objectives that our clients outlined for us were, they wanted us to create a projection surface which could be interacted with using bare hands, and they wanted it to be suitable to run Windows-based applications as well. They also wanted us to research different gestures to interact with the screen, and for that purpose we have demonstrated a proof of concept of navigating through a 3D environment using gestures on this surface. And there's also manipulation of 2D data within the 3D environment. We also were asked to research and recommend a voice recognition software which is capable of converting speech to text. Next. So by half presentation, we had decided what technology we wanted to go ahead with, and that was frustrated total internal reflection, or FTIR, and we were also deciding what kind of software should be used to make applications on the surface. Parallelly, we were also researching off-the-shelf products which are available in the market, and we found that there's this, if you see this image, there's this company called Multitouch in Finland, and they make these multi-touch cells which can be assembled make a screen of any size, and these cells have the feature of where it can detect and differentiate right hand from the left hand. And we were also researching different ways in which we could navigate through the 3D environment. Next. Let's look at some of the user testing we did. On week 9, we had prepared paper prototypes of multi-touch gestures, but we had also thought out different kind of menu options that we could use for the surface. But after testing, we realized that many people weren't keen on menu-driven options. They were more interested in just using plain gestures to interact with the screen. By week 11, we did an informal user test to test how intuitive it feels to navigate through our 3D environment. Week 13, we did an internal user test just among the teammates, because at that time we were trying to add as many features as we could for our application, and so simultaneously testing and developing was difficult since we only have one screen. Next. By soft opening, we had a screen which was well polished and it was very receptive. Some of you have touched it, and so I'm sure you would agree with me. We built a much more robust stand for our prototype, which is held firmly in place thanks to Bernard Carter, who is from main campus. We had also successfully achieved our objective of conceptualizing a 2D workspace within a 3D environment, and Tedo will show you a demo of our 3D environment which we have made in Ogre. He's going to play the video now. So in the video you see that you can navigate through the 3D space using swimming gestures, because this is like an underwater world. So you move like this to go in front or left, right, and there are 3D objects within this environment, and if you touch them you can get information based on it which you can manipulate. Next slide. So Ross is going to discuss some of the design changes.
Yeah, thank you, Dave. Oh, well, this is a graph showing the changes in our design over the whole semester. And before I start to introduce this graph, I want to show you one more feature in our application. Now, look at Tedo. He's trying to pull out another slide, which means we can display multi-slides at the same time. And we believe this feature can definitely help a presentation go more smoothly, and especially for comparing different kind of data. So look at this graph, and you can see that in the very beginning of this semester, we worked really hard on designing. Because we did a lot of brainstorming here, we want to create some creative gestures and intuitive interfaces. And for our software part, the programming part, we discussed with the faculties, and we get feedback that we choose to use OpenCV and TouchLib library to implement our application. And for the hardware part, yeah, we did a lot of research on internet, because multi-touch is not it's not an old technology, and we found there is no existing hardware solution for our project, which means we have to build our own hardware. Then during the half of this semester, you can see that we spend most of our time on building our hardware. Why? Because we have some problems. So in order to solve these problems, we try different materials. And we also try different visible light filters to solve our problem. Then for the software side, programming side, we choose Ogre 3D as our engine, and cooperate with TouchLib library for building our 3D demo. And we also decide to make a fresh demo for illustrating on-screen keyboard option. And for our design, yeah, design slide please. Thank you. For our design, we come up with 3 original ideas for our demo, for both soft opening and our final presentation. Then let's take a look. After the soft, we change our focuses to the software. This is because we decide to make our application as a presentation tool. We want to do today's presentation in our application. We think it's meaningful. So it's